Today, on Guess What I Found Out, the ocean has been holding a rave for 500 million years, and, well, nobody sent us an invitation. We're talking about bioluminescence, or as I like to call it, the ocean's way of saying we don't need the sun. We are the light. And the numbers here are genuinely absurd. More than 75% of all marine organisms are capable of producing their own light. Let that sink in for a moment. 3 out of 4 things swimming around in the deep right now are basically walking, glowing nightlights. That's not a quirky little fun fact. That's a whole civilization built on neon. Now, if you've ever wondered why your backyard doesn't glow, why the forest isn't just a pulsing disco of living things every night, don't worry. That's exactly what we're getting into today. And the answer is so much weirder than you think. Here's the thing. Curious George, bioluminescence didn't just evolve once in the ocean and spread around. It evolved independently at least 94 separate times. 94! In fish alone, it showed up intrinsically, meaning the fish makes the light itself, about 8 times. And it evolved using hosted bacteria at least 17 more times. That's like if 94 different engineering teams, none of them talking to each other, all independently invented the light bulb, but made of crab. So what is actually happening when something glows? Inside the organism, a molecule called luciferin gets hit by an enzyme called luciferase. A chemical reaction kicks off, and out comes a photon of light. No heat, no electricity, just pure, cold biological light. Different creatures use chemically distinct versions of these molecules, so luciferin is more of a job title than a single molecule. Same function, completely different chemistry, evolved over and over again in creatures that share almost nothing else in common. And that is why I need you to smash that like button right now, because the ocean basically cheated on evolution's final exam and got the same answer 94 times. Now, why the ocean? Why not land? Why not fresh water? Why is the deep sea glowing like a Las Vegas strip while your local forest is just dark and full of owls? Part of the answer is real estate. Most of the ocean is open water. No trees to hide behind. No rocks. No leaf piles. The pelagic zone, the big open ocean, is essentially one enormous 3-dimensional arena with nowhere to run. So marine life had to get creative, and well, light turned out to be one of the most creative tools in the box. But there's also the physics of water. In the mesopelagic zone, about 200 to 1,000 meters down, sunlight still trickles in from above in faint blue-green ribbons. That means a smart fish can use its own light, placed on its belly, to match that ambient glow and completely erase its own shadow from any predator looking up from below. This trick is called counter-illumination, and it is genuinely elegant. You're not hiding in the dark, you're hiding in the light. The Hawaiian bobtail squid even adjusts the brightness of its belly glow depending on the time of day. It has a circadian light schedule. It's basically setting a daily alarm to update its own camouflage. Let's talk about the tactical applications, because marine bioluminescence is not just pretty. It's a whole Swiss Army knife of survival strategies. Defense comb jellies fire sudden flashes to startle predators. Ostracods, which are tiny crustaceans so dramatic they've earned the nickname sea fireflies, blast a luminous slime when attacked. The slime coats the predator, marks it, and actually attracts bigger predators to come eat the thing that was trying to eat you. That is not just defense. That is psychological warfare. Now, predation in the deep sea is, well, a bit of a light show. Anglerfish dangle a glowing lure off their forehead to draw prey directly into their mouths. Giant squid have been observed flashing bright lights while hunting, possibly to stun prey or to signal at close range. These are apex strategies that only work because light behaves predictably in water. On the communication front, lanternfishes have glowing spots on the sides of their heads, and researchers believe those patterns help individuals identify their own species and find mates in the dark. Humboldt squid produce rapid shifting light patterns in different social contexts, possibly flagging dominance or food claims. It's basically a very terrifying Slack notification system. Now, here's where it gets philosophically interesting. If water is so good for bioluminescence, why isn't freshwater just as glowing as the ocean? Both are aqueous. Both could theoretically dilute any toxic byproducts from the chemical reactions. But freshwater environments are nearly dark, almost no bioluminescence at all. This suggests it's not just about chemistry or the water itself. It's about evolutionary history, ecological opportunity, and what optical tricks are actually useful in a given habitat. The ocean has hosted life for far longer than land has. Marine lineages have had hundreds of millions of years to experiment, fail, and stumble onto bioluminescence again and again. On land, the first glowing organisms were relatively recent newcomers. Fossil evidence places an ancestor of fireflies with a light-producing organ about 100 million years ago. Glowing fungi appear to have originated around 160 million years ago. Ancient by human standards, sure, but practically a toddler compared to what's been brewing in the deep. On land, evolution also simply had other options. Dense forests, burrows, leaf litter. If you can hide behind a tree, you don't need to outthink a predator with a belly full of photons. Hold on though, we're almost to shore. Here's a parting thought that scientists are actually debating in the context of looking for life beyond Earth. Bioluminescence may one day serve as a biosignature, a detectable sign of life on another world. Planets with liquid water and an atmosphere might plausibly host organisms that glow. Which means the same weird evolutionary arms race playing out in our oceans right now might be flickering away on some distant dark world we haven't found yet. So the ocean glows because it's open, ancient, optically tuned for light-based tricks, and frankly has had a lot more time to figure itself out than anything on dry land. 75% of marine life is bioluminescent. Bioluminescence evolved independently at least 94 times. And the deep sea is, right now, an ongoing light show that makes anything we've built on land look deeply unimaginative. If that kind of brain-melting nature content sounds like your kind of party, hit follow on Guess What I Found Out. And drop a comment below. Do you think bioluminescence could ever become as widespread on land as it is in the sea, or is the ocean just built differently? I genuinely want to know your reasoning.